sessions that we'll be talking about for HAPI. So I mean, you could even get a preview of what's in the advanced and the server topics if you want, and that would maybe help you decide if you want to do that or if you would rather spend your time coding during those times. So there we go. I will also mention before starting anything else that these slides, of course, are all they're all free. They're all Creative Commons licensed, so you are certainly all welcome to take this presentation and give it to other people, share it with other people, do what you want with it. Creative Commons is a pretty open license, and we're a big fan of that type of thing with HAPI, so by all means, take advantage of that. There is also a GitHub page at github.com/furore-fire/firestarters. All of the code samples that we will go through in this tutorial are all available up on that GitHub repo. There are also samples for a number of other languages. So all the Java stuff is in there. There's also .NET, there's some iOS stuff, there's some JavaScript stuff in there. So if you want to try playing with lots of different languages with Fire, that is a great place to go, actually. So you'll find lots of good stuff in there. So, a bit of background for me. I see lots of familiar faces and a bunch of unfamiliar faces as well. I am a software dev myself. I suspect, probably like many of you guys, I'm not a medical person. I come from a software engineering background. I have been the project lead with HAPI for, actually, I think it's about 15 years now I've been leading that project. So of course we started with a V2 library and then moved on eventually to Fire, and I've been doing that for a good long time. Outside of that, I work really kind of two big hats or wear two hats in my life. I am the lead architect for a place called the Center for Global E-Health Innovation. We're a research lab who build medical apps for chronic condition management. And then the other half of my life these days, I am the CTO for a little startup called Smile CDR. We've got a booth over in the back of DevDays. We'd love to chat with you guys. And we're building a Fire-based clinical data repository that is, we think, pretty cool. And of course, built on top of HAPI. So a lot of this technology is relevant to us there. So I'm going to start, I guess, by asking, how many of you guys have used HAPI before? Okay, so actually, probably half the room. What are you doing in here? This is the beginner tutorial. That's cool. Right. So I will say quickly, this of course is a Java library tutorial, so I'm kind of assuming here that you're familiar with the basic concepts of Java. I'm also assuming that you've used Maven, the build tool, before. If you haven't, not a huge deal, but certainly Maven is used in all of the code samples if you want to get started with that. So if you've never used Maven before, I mean, it's not a huge deal. Come and find me after this, and I'm happy to get you to help you get a build environment going so you can play with it. So the agenda for today, actually I'm going to skip the agenda slide because I've got a better one coming up in a minute. I'm going to start with just a quick recap, of course, about what Fire is. So Fire, naturally, every time I explain what Fire is, I always just say, really Fire is kind of two main concepts. There's lots to it, but it's pretty simple. First off, oh, that's in a funny order. I'm missing a slide. Oh well, whatever. So thing number one, for which of course the slide disappeared, Fire is this beautiful data model. And it represents, of course, all the things we have in healthcare. So it's this wonderful healthcare data model for your patients and your observations and your encounters and your doctors and your lab tests and all of that stuff. So there's just this really nice, really well-defined data model. That's what would have been in slide number one. And then thing number two is it's just this really nice API for interacting with that data. So it's this beautiful sort of RESTful API that lets you construct powerful queries for getting at data, makes it really simple to create new data and update data and interact between your clients and your servers. So take that combination of the really nice data model and the expressive API for interacting with it. That's kind of the heart and soul of what Fire is. There we go. Fire, of course, has had a number of releases in its time in existence. We started with DSTU1 back in 2014. DSTU2 was released in 2015. R3 has just been released as of this year. And naturally, at some point in the next couple of years, R4 will be released. The current scheduled date is late 2019, so we'll see if we stick to that. All of the material here today sticks to the latest version, which is R3. And I will mention there is a sort of a long, complicated naming history with FHIR, where we started with the term DSTU, and then we moved to the term STU, and now we say R. If I say DSTU3 or STU3 or R3, they all mean the exact same thing. It's just a force of terrible habit that, because it's changed over time, I've never really gotten used to the naming. So don't infer anything from my using those terms interchangeably. They all mean the same thing. It's just release 3, basically. So, a tiny bit of background on the HAPI project. So HAPI has been around since 2001, actually. It was started as an HL7 version 2 parsing library, and it was built really just to support this sort of simple use case of, we wanted to build a website, we wanted it to talk to a couple of EHR systems. Those EHR systems spoke HL7 v2. We couldn't find any open source tooling way back then, so we started a little library for it, and the HAPI project was born then. It's gone on to become all kinds of crazy things since then, but HAPI in its start was just this really simple open source library for healthcare, probably one of the first libraries out there that was open source and focused very strictly on healthcare. So it has an interesting history from a long time ago. The HAPI FHIR library started in roughly 2012, so maybe a year into the existence of FHIR itself. We got interested in the idea of doing an open source library for HAPI for FHIR and kind of started it from there. So let's talk a little bit about how the library is set together. All right, so I will start with a bit of information on sort of our design goals. So HAPI FHIR, of course, first off, we are an open source project, and we believe deeply in sort of the ethos of open source, and we have a couple of basic goals here. The first is that we want the library to get used. So we're Apache 2 licensed, which means really there are very few restrictions on how you use the software. We very much encourage you to put it into proprietary software. If you're intending to build a product and make your product a closed source and put HAPI inside there, we completely encourage you to do that. We're big fans of that, and we've had lots and lots of contributions over the years from people who are building products they sell, and we think that's pretty cool. We are very much into sort of making the library flexible, and the example I always give there is we are influenced quite heavily by the Spring framework. For those of you guys who are Java developers, you've probably encountered Spring. People love and hate Spring at the same time. The thing that Spring does really well is it's this beautiful modular library system where if you want one specific function, you don't need the rest of Spring for it. You can use that one thing, or you can use the entire stack from top to bottom. And we've tried to design HAPI to work the same way. So if you need the entire full stack of a server, you can use it, but if you just need one bit of the parser library, that's an option for you as well. We've tried to do that. And of course, we have stolen lots of ideas. We try and emulate the best things in other libraries. The biggest one there being the .NET reference implementation for FHIR. So we've taken many good ideas from them over the years, and they've taken a few from us as well. So we have a good give and take there. HAPI FHIR comes from a few places, so we are supported very generously, actually, by the Juvenile Diabetes Research Fund, who have an interest, actually. It seems like kind of a funny fit, but they, as an organization, have a big interest in standards for helping diabetes care, and of course, FHIR these days is very big in the device interoperability space, so they've funded us quite well over the years to build up a tool chain of open source tools for diabetes care. And that, of course, has helped our library development quite a bit over time. So, this is a rough overview of the modules that sit within HAPI, and there are a number of them. We've got a set of, basically a set of data model classes. We've got a parser, we've got stuff for clients, we've got stuff for servers, we've got some validation tooling, we've got narrative generation tooling, we've got some testing tooling, and a command line interface. This isn't even an exhaustive list, but it gives you a good sense of some of the modules. The breakdown here for the 3 sessions going on at DevDays this year is as follows. So this presentation, the beginner's tutorial, we're going to talk about the data model, we're going to talk about parsing, and we're going to talk about clients. We've got the server tutorial comes next, so we'll be talking about server and JPA server. And then finally, we're going to talk about validator and the web test page overlay in the advanced topics. And there's a few I've left an extra circle up at the top just because I like to sort of leave some time for anything that comes up during the during the hackathon portion, somebody will come up with something that we realize is not so useful, or is not so well covered, rather, and we will add that as well. So we've got some time for whatever extra advanced topics come up during the course of the next couple of days. So let's start by looking at the data model and the way that works. So the first place to talk about the data model, this is kind of it's a weird concept. It's simple, but it always trips people up. And that's around versioning. So it's sort of important to understand that FHIR, of course, is a version standard. We've had a few releases of FHIR over the years, DSTU 1, 2, 3, and finally 4. And of course, we have had a few releases of HAPI over the years, and those two concepts are completely independent from each other, actually. So every new release of HAPI will support, in parallel, a couple of versions of the FHIR standard. So as you can see from this little table, HAPI FHIR 1.0 just supported DSTU 1, and it had an early draft of DSTU 2 supported. By HAPI 2.0, still supported DSTU 1, we supported DSTU 2, and we had an early draft of R3. By HAPI FHIR 2.5, we were supporting 1, 2, 3 in parallel. And as of HAPI FHIR 3.0.0, which was just released maybe 2 months ago, we have finally dropped support for DSTU 1, and we've got the first early draft of R4. So if you're using HAPI in this hackathon, I mean, you're probably using the latest version, 3.0.0. You might even be using a pre-release 3.1 snapshot build. Either way, you're going to have support for, in parallel, both DSTU 2 and 3, and you'll have support for the early versions of R4. I will also mention you are, within the library, certainly able to use multiple versions of FHIR in parallel. We've had lots of people with complicated needs where they basically need to support a few versions of the standard in parallel, and there's nothing stopping you from doing that within the library. It certainly tries very hard to support that type of use case. All of the versions of FHIR we bundle into these things called structures jars. So essentially when you're using the library, one of the things you're going to do is import into your Maven file or your Gradle file or your Ant build or however you're building things, one or more of these structure jars. So HAPI FHIR, structures, DSTU, that's the version of FHIR we're supporting, and then 2.5, that's the HAPI FHIR version. So you'll be importing one of those things, and then sitting within those classes you've got, or sitting within those jars, you've got classes that represent the various sort of models. So you can see within the DSTU, we've got HAPI FHIR model DSTU. Within DSTU2, we've got a package named DSTU2, and then we move on to 3, and finally R4. So we've basically got 4 classes named patient as a simple example, and each one of those has a different package name and represents a different version of the structures. So let's start by talking about resources. So basically, FHIR, of course, defines this set of, I think it's something like 160 resources these days, this fairly significant number of resource data models. HAPI FHIR defines a class for every one of those resource definitions. So, for example, FHIR defines a patient resource, an encounter resource, a practitioner resource. You will find within the jars a patient.java, an encounter.java, and a practitioner.java that corresponds to all of those. Every one of those classes all implement this sort of super interface called ibase resource, and then underneath ibase resource you will have, in a specific package, a resource definition for an individual resource. Within those resources, we have a bunch of data types, and I've got a few examples up here. So recall from the beginner tutorial, the FHIR introduction tutorial rather, there are 2 types of data types that sit within FHIR. So we've got a set of primitive data types, so those are things like strings and decimal numbers and booleans and things like that. For every one of those, we have got a data type class that represents that. So for FHIR's concept of a string, we've got a class called string type. For FHIR's concept of a decimal number, we've got decimal type, and so on and so forth. FHIR also defines a set of composite data types. So these are things like human name, where you've basically got a structure that represents, the family name and the given name and any prefixes and suffixes and things like that. All of that is bundled into a composite data type in FHIR that's called human name, and there is a class that corresponds to that called human name. And human name, of course, is made up of a whole set of strings that are your family name and your multiple given names and things like that. We get asked, a fairly common question actually is, why does string type exist? Because of course Java has a class called string, so why did we create our own string? So I'll answer that quickly, but it makes more sense when you get to the actual need for it. Ultimately, the reason we have these wrappers is because of the concept of extensions in Fire. Fire has this funny property that you can add an extension to absolutely, well, almost anything in the data model can get an extension. And primitive data types are no exception to that rule, so it certainly is quite possible for you to have a family name and then have an extension on that family name. So the string type basically is this wrapper on a Java string that allows you to add extensions. And when we get into the code that uses it, you'll sort of see how that fits together. You don't necessarily ever need to interact with string type, the class, but I always need to explain that because people think it's kind of weird that we've created our own concept for string. Java docs are all available for all these versions. Here are the examples. I'm going to click on one just to sort of take you there. And of course, I'm sure you've all seen Java docs before. This looks just like any other Java doc you will ever see. Naturally, there are lots of documentation for, there's documentation for all the different properties and all the things that are in there. And of course, if you're using an IDE, if you're using Eclipse or IntelliJ or whatever, you can naturally add the source jars and the Java doc jars and all of that and get nice autocomplete that includes documentation for what you're doing. And that usually makes things a lot nicer to deal with. So let's start by looking at a little bit of code. So we're going to create a resource first off. So to give you a simple example of how you interact with the data model here, we're going to create a patient class, or an instance of a patient class. So every one of the Fire resources, of course, corresponds to a Java class, and as you would expect, creating a new patient object is as simple as calling the constructor on patient. So patient pat equals new patient. We then will add a name, so this seems like a fairly trivial and simple example of something you'd want to do. Every one of the properties that sits on patient, there are getters and setters. If something repeats, there's probably going to be an add method as well, so we will call add name. Add name gives us this instance of this thing called human name, which is the data type. We will populate the data type with a family name, and we'll add a couple of given names. We'll look at adding identifiers. We'll look at adding a second identifier. While we do that, I will mention a couple of things. First off, use your IDE autocomplete. I mean, I'm sure I don't need to explain this to anyone, but as I was saying, add the source jars, add the Java doc jars and all of that to your IDE, and you will have a much nicer time dealing with the structures because everything is designed so that your autocomplete will help you sort of navigate the structures. That's thing one. And then the other thing I will mention here is that we've sort of built the API around this idea of fluent chained calls. So everything in HAPI, almost everything anyhow, is designed to be chained. So you'll sort of notice as we're creating human names, we're calling set family, and then chaining on that, we're adding a given, and we're adding another given. We've sort of designed this so that it should be possible for you to just chain things together almost indefinitely, so that you can kind of really simply construct the values you need within your resources. So, if you have a look, as you start to interact with the API, all of this sort of starts to make sense, hopefully. But you'll see that everything chains quite nicely together, which makes it a little bit nicer to deal with. There are a number of enumerated types within the API as well. So you will see, for example, we are creating a contact point. So contact point is a data type that deals with things like phone numbers, email addresses, that type of thing. Contact point has a couple of coded values. These are sort of fields that accept only a set of allowable values that are defined by Fire. For any of those, we've defined enumeration types for that. So you'll see this Java enum called contact point use and contact point system. Those are sort of peppered throughout the API at any spot where we've got these things called required bindings to codes, which is basically Fire's way of saying you can only use one of these, this set of codes for a specific value. So, of course, in Java, you've got the concept of an enum, and we use that for that particular point. So I will mention, I was saying that we have these wrapper types for primitive data types. You will see sort of within the library a fair bit. There's a few ways of accessing those. Everything in Fire, of course, has a string representation. So Boolean has been defined by Fire as being, Booleans have been defined by Fire as being the string true or the string false, just as it is. You can always interact with these primitives by using some sort of Java primitive. So, of course, Java has a Boolean as well. You can use Java Booleans. You can also use the string representation if you want, and these are sort of useful as you're building up, whatever it is you're trying to build. Decimals work no different, so Java has a concept of a floating point number, of course, as does Fire. And you can always interact using sort of Java's native constructs. You can also interact with the string representation. This example here is kind of a useful one to point out, just because Fire, unlike Java, does care about precision. So naturally, if you put a string in that's 1.2 with a whole bunch of zeros after it, HAPI is going to remember those zeros. It will keep track of how much precision you've got. Internally, it keeps track of both the floating point representation of it as well as the string representation. So that level of precision never gets lost, and will always come back to you if you need it later. What else is worth covering here? So you'll notice also, I was also saying you might not even ever need to deal with those primitive things like the string type. Most parts of the library provide these convenience methods that sort of hide the Fire primitives away from you. So for example, an observation can take a comment. There's just a simple string field on observation called a comment. And as you interact with that, you will have a setter that just takes a plain Java string. You can also interact with this other method called setElement, which allows you to pass in the Fire primitive string type in there. So you've always got sort of ways of dealing with the underlying Fire primitives if you need them. If you don't need them, there are usually ways of just dealing with plain Java primitives as well. So plain Java strings and Booleans and decimals and stuff like that. So that is the model in a quick nutshell. I could spend probably the next several hours talking about the model. There's a lot in there, but ultimately it's fairly self-explanatory actually. I think once you start playing with it, the hard part of course is understanding where your data should go in the first place, and Fire's data model is getting bigger and bigger over time. But I think HAPI FHIR does a pretty decent job of at least making it easy to sort of navigate all of the underlying power of that model. So let's talk about parsers and serializers for a second. So I will say a couple of things. Let's start with actually what's point 2 there. So Fire defines a couple of serialization formats, a couple of sort of wire representations of its data. They actually define 3 that are defined as first-class citizens of Fire right now. There's an XML representation. There's a JSON representation, and they've defined a third, an RDF representation as well, using a format called Turtle. HAPI has built support for the first 2 of those, so there is an XML parser and a JSON parser built into HAPI. At some point, I still hope that we'll add support for RDF, but we haven't had a lot of people ask for it, so it's been relatively low on our priority list, although I know at some point we're going to have to get that in there. The 2 parsers are both very much first-class citizens. They both support the full feature set. There's never any reason for you to use one over the other. I will say personally I much prefer JSON, so most of my examples deal with JSON, but the XML support is every bit as good. And they both perform sort of roughly equivalently too, so there's not really any reason to use one over the other. I guess that was thing 2. So thing 1 is the sort of starting point for everything within using the HAPI library is this class called FireContext. So you will see at the start of all of the sample code that I give you pretty much, the very first thing we do always is ask for an instance of the FireContext class. So your FireContext is sort of HAPI's internal mechanism where it keeps track of what the data model looks like. You use it as a factory for parsers and all the other things you want. I will try and underscore as much as possible. This third bullet here is super important as you're building any code using HAPI. Create one instance of the FireContext, keep it around, don't ever get rid of it, and don't create a whole bunch of them, just because it's kind of an expensive class to create, and you can reuse it as much as you want. The deal is, it is fully multi-thread capable. You're never going to run into synchronization issues. All of the methods on it are, you never need to worry about sort of synchronization issues with them. On the other hand, if you create a new FireContext for every payload you're parsing, you're definitely going to be a lot slower than you would be otherwise. So, make sure to be reusing your FireContext class. So let's give a quick example of encoding a resource. So again, I'm going to create a new patient, just as I did in my last example, and as you can see through all of the method chaining, I managed to get a whole bunch done in 4 lines of code, which is kind of nice. The next thing I'll do is create a context object, which sits right there. The thing you can do if you want to parse, basically, if you want to parse or encode, all you need to do is create a context and then ask the context for a parser. So I say ctx.newJSON parser. I can configure that parser if I want, and the first thing I'm going to do, and I often do this when I'm writing sample code, is I say set pretty print to true, which of course just means we get nice indenting and the output looks a little bit more nicely formatted than it would otherwise. And then parser's got a bunch of methods for encoding. So the easiest one is this method encode resource to string. So I pass in a resource object, that's this PAT variable, and out comes a string, which I will encode. So if I run this code, what will come out, of course, is a little JSON, a little bit of JSON formatted code. So, I mean, as you can see, really all we've got there is about 10 lines of code, and we've very quickly whipped up a simple FHIR resource, and we've encoded that out, and that's all that took. If we want to go the other direction, naturally, again, we ask for a parser. So this time what I'm going to do is I've got an encoded string, which is a full resource, and it's all of its properties. They're not formatted the nicest, but there you go. I will, again, create a new context. I will, again, ask for a parser. And this time on the parser, I'm going to call this method parseResource. And there's a whole bunch of ways of parsing. The simplest one, though, is I give it a class and I say, this is the type I want you to parse in, and this is the payload I want you to parse, and out comes a patient resource. And I've got a simple example here where I'm parsing it and looking for an identifier and just printing out what the identifier is, but I could just as easily save it to a database or really do anything else I wanted with that parsed resource. So, that is, I mean, that's in sort of a quick nutshell, everything to do with the model, everything to do with parsing. Let's talk a little bit about the client. So this is really where things start to get kind of fun. So, of course, FHIR defines this really nice REST framework that gives you a whole bunch of ways of searching for data and pulling data out and storing it on a server and all of that. And naturally, FHIR has sort of, or HAPI has created a client that allows you to do all of those things as well. There are two flavors within HAPI of clients. We've got this concept of an annotation client and this concept of a generic client. If any of you have ever used basically a REST framework, things like like Spring's REST framework or REST Easy or JAX-RS is very popular. All of these frameworks, or most of these frameworks anyway, work on this concept that you create an interface and you give it some special annotations that sort of map to what you're doing. HAPI has a client that works that way as well. That's called the annotation client, and you can sort of see a simple example here where you basically create an interface and give it some annotations. That's method one of using HAPI's client framework. Method number two is this thing we call the fluent framework, which is basically you use method chaining and sort of construct things like that. All of the examples I'm going to give here, I'm using actually the second form, the Fluent client, just because it's a little bit easier to get started with. It doesn't require creating interfaces or anything like that. But both of these methods work, and they both support all of the same functionality. So there are examples of the annotation client in the GitHub repo I mentioned earlier. So if you want to try that one out, that's an option as well. And here's a link to the documentation. So all of this is available on HAPIFHIR.io. Actually, I'm going to click on one of those just to show you where to find it. So if you're trying to find documentation for any of the client, I'm just going to go back to the home page. HAPIFHIR.io, this is our website. If you go into documentation, go to RESTful client, and then I'm going to click on the very first link. This is all of the documentation around the Fluent client, and oops, that's not what I want. There we go. And that will show you basically everything you need to know in there. So let's start with a simple example of creating a client. So if I want to, or creating a patient. So if I want to create a patient and save it on a server, the first thing I'm going to do, of course, just like I was doing before, is I will create a patient object. So I do all the stuff I did before. I create this variable of type patient. I populate it with some data. Once again, I ask for a context, but now things change a little bit. I am going to basically say CTX, so again on my context, I'm going to say give me a new RESTful generic client. And that method takes one argument, and that's the base URL for a server. So here I'm using, the example I'm using here is our public HAPI test server. So this is this thing called firetest.uhn.ca. This could just as easily be your server or any of the reference servers or any of the other servers that are out there. As long as you have the base URL for a FHIR server somewhere, you just pass that in and you've got a RESTful client. And then of course the client uses this nice mechanism, this Fluent mechanism, to chain together a bunch of methods to do things. So the example of creating a patient, I will say client.create, and then the next block in the chain is what resource I'm creating, and that's .resource, and I throw in this variable for the resource I'm creating. And then every client call always ends with .execute. And this is kind of a gotcha. People sometimes find this confusing, but every time you are trying to call, basically if you're using HAPI's Fluent client, your chain is always going to end in .execute, and nothing gets done until you call .execute on the chain. So if you forget that last step, nothing is going to be created on your server. So this trips people up sometimes, and they wonder why it's not working. So if whatever you're trying isn't working, make sure you've got .execute. That method returns this object called method outcome, and method outcome has a number of things in it. Most importantly, it's got the ID of the created resource. So the server will create that resource, it will save it in its database, it will give it an ID, and it will return that ID. That actually comes back in this header called location, so an HTTP header called location. HAPI parses that and then puts that back in this ID. There's a few other things you can get back from method outcome. So if your server has returned an operation outcome resource, which is the status resource it's allowed to return, you can get access to that through the method outcome as well. If your server returned you some weird error message or something like that, you can also get that through method outcome. So there's a number of properties of method outcome, and you can use that to find out what happened in the call to the server. Updating a patient works roughly the same way, so I've got sort of a simple example, and I'm going to go through that just because I think this covers a couple of interesting concepts. Let's say I just saved my first resource to the server. Of course, the server would have given it an ID and all of that stuff. I'm now going to read it back. So this next example, I say client.read. This is a read to retrieve an individual resource. I'll say .read, and then I'll say .resource. And I tell it what type of resource I'm trying to read back. I say with ID, so I'm looking for a resource with the ID example that's sitting on the server, and it's of type patient. I say .execute, and what comes back? A patient resource. So I will log the ID, as you can see here. And what I'm going to do is I'm going to change the gender. So this example, I mean, it's a bit strange example to look at, but this same example sits on your server. Or sits in the GitHub repo, so you have the ability to go through and try this yourself. And what it does is it reads back a patient, changes the gender between male and female, and then updates it back on the server. So you can always run this, and it will always just flip-flop that one property. And we do the update by saying client. Oops, get out of there. By saying client.update.resource, and of course this thing is covering it, but it says .execute underneath the bit that's covered right there. There we go. So I've got 5 minutes left, and I knew I was going to run out of time a little bit. I will talk quickly about searching. So HAPI defines this really nice mechanism for searching. Searching in many ways is really the most powerful part of the FHIR API, just because it's really simple to create these really complicated searches. You know, if you want to do a search for find me any observations that are lab tests, which are biochem tests, which belong to a patient who is male and over 65, there is a URL which represents exactly that. HAPI has tried to come up with its own way of representing all of the power of the FHIR API using, again, these nice method chains. So I've got one simple example, client.search for resource where this and this, return up to 100, and return this type of bundle. This is one simple example, and searching is a topic, again, that I could spend an hour talking about, and of course we don't have time for that. But HAPI's website, in the client section, there is examples of every single part of the search API. So certainly I would encourage you to spend some time looking at the examples there. And if you're trying to figure out how to do a search and it's not coming to you, I will be around, and there's a bunch of HAPI experts sort of walking around this place. So there's lots and lots of ability to find examples of how searching works. I will mention quickly, there is lots of other stuff in the REST API, version-aware updates and fetch if something hasn't changed. Basically there's all kinds of power in the FHIR API, and most of it is supported by the client as well. And naturally, don't have time for an example of every one of those, but it's all documented on the HAPI website as well, so there's lots in there. I will mention quickly, HAPI has this concept of interceptors. So an interceptor is essentially something you can add on to your client that wraps some specific functionality into it. There's a bunch of examples baked into HAPI itself. So we have interceptors which will log every request and response. That's really useful if you're debugging. We've got interceptors which capture the request and response, which is also good for debugging. Basic auth and bearer token auth, which will add authentication tokens to your requests and your responses. You can also create your own interceptors, and I've got examples within the GitHub of custom interceptors for things. So if you've got a need to add some custom header to your request or to capture some weird header from your response or something like that, an interceptor is a really easy way to do that, and the API is designed to be extensible to allow you to do that as well. So that concludes the first tutorial, and we're, I guess, right on time. That's good. So I will mention once more, github.com/furore-fire/firestarters is the example. If you want to try playing with this, we've got an example called Client Skeleton, which is basically a little skeleton project, implements, gives you a Maven POM file and some basic classes to fill out. So this is a great way to get started with the client. There's a bunch of suggestions in that class for things you can try next and all of that. So this is probably a good spot to break for an example. So thank you, everyone.